Hello everyone, I'm Money Daily, a high-stakes battlefield that could decide the future of tens of trillions of dollars, and the battlefield fits right in the palm of your hand. Figure 03 implants the so-called Eye of God directly into its palm, using sensory redundancy to overwhelm its competitors. Elon Musk, on the other hand, sticks to first principles and refuses to give Optimus any hardware cheat codes. So which approach wins? Does extreme hardware stacking triumph, or does Tesla's minimalist philosophy once again deliver a dimensionality reduction strike? Today, we're peeling back the surface and diving deep into one of the most hardcore sensory wars in robotics. Don't miss this one. All right, let's go. Today, we're talking about a battle that doesn't happen on the road, it happens in the hand. We're talking about palms. Before you look at your own hand, look at these two images on screen. On the left, a silver, highly mechanical design, Tesla Optimus, Elon Musk's own child. On the right, a black hand that almost looks like it's wearing a high-tech bodysuit, the recently viral Figure 03. Do you see the difference? Beyond color, the biggest difference is right in the center of the palm. Figure 03 has an eye, an embedded camera. Optimus has a smooth, empty palm with no visible sensors at all. This isn't a cosmetic difference, it's a fundamental design decision. Behind this lies two completely different technological paths, two opposing worldviews, and arguably a trillion-dollar gamble. On one side, Elon Musk's first principles thinking. Humans don't have eyes in their palms, yet we can still thread a needle. So why should robots need one? On the other side are newcomers like Figure AI and Sandy Robotics. Their argument is simple. If we're building robots, why not give them superhuman perception? Today, we'll strip this down using hard data and first principle logic and dive into what may be the most exciting sensory war of 2025. This will be dense and technical, but if you stay through it, your understanding of humanoid robots will likely surpass that of many Wall Street analysts in suits. Buckle up, we're accelerating. If you enjoy this kind of deep analysis, please like and subscribe. It's the biggest support you can give me. First, let's examine the Eye of God faction. Figure 03 and Sandy's luxury hardware stacking philosophy. Let's start with the hand that can see. Figure 03's goal isn't just to look, it's to see through. This isn't just drilling a hole and slapping in a camera. According to Figure AI's latest disclosures, this is a full palm-level perception system. Why does this matter? Imagine reaching deep into a cabinet to grab a jar of chili sauce. Your head-mounted camera can see your hand going in, but the moment you actually grasp the bottle, your arm and wrist block the view. This is known as the occlusion problem. Humans solve this with touch. Our fingertips are packed with nerve endings that detect shape, temperature, and friction. Robotic tactile sensors, frankly, are still far from human level. So Figure's engineers took a different route. If touch isn't precise enough, then see up close. The palm camera gives the robot a macro-level visual perspective. According to their data, this system expands the field of view by 60%. That means when the hand approaches an object, there are almost no blind spots. The robot can clearly see the relative position between its fingers and the target. Another key advantage is ultra-low latency. The frame rate is double that of the previous generation, while latency is reduced to just 1/4. In robotics, this is called high-frequency visual motion control. In plain English, even if you throw a bottle at it, the robot can track its trajectory within milliseconds and adjust its hand posture to catch it. And the hand doesn't just see, it also feels. Figure 03's fingertip sensors can detect pressure as low as 3 grams. What does 3 grams mean? That's roughly the weight of a paperclip. This allows the robot to sense the micro vibrations right before an object slips. Combined with high-speed data transmission, this hand becomes a mobile data center. Everything it sees and touches is instantly uploaded to the brain, forming a closed feedback loop. This is Figure's core philosophy: sensory redundancy. They don't trust a single sensor. They flood uncertainty with massive amounts of data. It's very similar to the LiDAR-first approach in autonomous driving. Cost is secondary to absolute reliability. Now let's look at Sandy Memo, which pushes household robotics to the extreme. Sandy Robotics made a bold choice. They didn't even try to build a human-shaped robot. Memo doesn't have legs, it has wheels. Why? Because in a flat home environment, walking legs consume more power, fall more easily, and scare pets without offering real advantages. Wheels are more stable, more energy efficient, and safer. But their hands are where things get interesting. Memo uses a simple 3-finger gripper, almost like a lobster claw. At first glance, it looks crude, but this was a deliberate decision. Do you really need 5 fingers to do housework? Think about washing dishes, folding clothes, or picking up toys. 99% of these tasks only require gripping and pinching. 5 fingers exist for playing piano or embroidery, not washing plates. For a dishwashing robot, 5 fingers increase failure rates and dramatically reduce cost efficiency. Now here's Sandy's secret weapon. Their real innovation isn't the robot, it's the data. They distributed over 2,000 motion capture gloves worldwide. Instead of locking engineers in labs writing code, they let ordinary people wear gloves at home while doing chores. This data is real-world combat data. For example, after washing a cup, people instinctively flick water off. Lab-trained robots never learn this. But by learning from thousands of humans, Memo did. This is behavioral cloning. Although Sandy and Figure take different paths, they share one belief: extra hardware can compensate for the current limits of AI intelligence. Now let's turn back to Elon Musk's Optimus. If you look closely at Optimus's hand, it's clean, almost minimalistic. No visible cameras, no exposed wiring. Is this because Tesla can't do it, or because Musk is cutting costs? Why doesn't Optimus have a palm camera? Anyone familiar with Musk knows his obsession with first principles. His logic is simple. Humans are the most general-purpose, intelligent beings on Earth, yet we don't have eyes in our palms. So how do humans thread a needle? We rely on vision, proprioception, and fingertip touch. So Musk believes a palm camera is cheating, a crutch. Worse, it could become an engineering nightmare. Think about it. The wrist needs to rotate 360 degrees. How do you route a signal cable through a constantly rotating joint? This not only increases the design difficulty, but more importantly, after millions of flex cycles, the failure risk becomes enormous. Durability is another concern. Hands do real work. They grab oily wrenches and rough bricks. If there's a camera in the palm, can you guarantee it won't get scratched or covered in grease? Once the lens is damaged, the robot is effectively blind. Imagine thousands of factory robots requiring manual lens cleaning. That's not automation. So if there's no palm camera, how does Optimus achieve dexterity? The answer lies under the skin. Musk has said the hand is the hardest engineering challenge, harder than building cars. Optimus has 11 degrees of freedom, fewer than the human hand's 27, but enough for most tool usage. The metal tendon system is especially bold. Like human fingers, which are controlled by forearm muscles pulling tendons, Optimus hides its motors in the forearm. High-strength metal cables pull the fingers. This allows the fingers to be thin, light, and fast. But it massively increases control complexity. You must precisely model elasticity, friction, and fatigue. Another advantage of Optimus is its pure vision and occupancy network. Even without a palm camera, its brain is powerful. Borrowing from Tesla's FSD technology, Optimus builds a 3D mental model of the world. When a hand obstructs the line of sight, the brain relies on a recent visual memory to create a 3D model of the scene, thus retaining a sense of where objects are located. This is object permanence, a hallmark of higher intelligence. At this point, it should be clear. This isn't about whether to add a camera. It's about three fundamentally different product philosophies. Figure 03 is like an elite special forces soldier, pursuing maximum individual capability at any cost. Its palm camera shines in chaotic, occluded environments and solves the final centimeter problem. But it's expensive, complex, and costly to maintain. What if the palm camera breaks down? What if millimeter wave transmission gets interfered with? Therefore, it's inevitable that initially it can only be applied in high-end scenarios. Let's take another look at Sandy Memo, the family housekeeper. Its philosophy is rooted in pragmatism above all else. If it washes dishes well, it doesn't need to look human. It's cheaper, safer, and learns fast through crowdsourced data. So it is the robot most likely to enter your dining room first, but it can't climb stairs. And its three-finger gripper struggles with ultra-fine tasks. For example, when it comes to threading a needle or picking up a coin, Tesla's Optimus is an industrial empire play. First principles plus mass manufacturing. Simpler structure, fewer failure points, and production at Model Y scale. If its end-to-end neural network matures, it could become the cheapest and most versatile humanoid robot ever built. But Optimus has its own risk. By rejecting hardware shortcuts, it demands God-tier software. If AI progress stalls or simulations fall short, Optimus risks becoming a clumsy, blind giant. Let's dig deeper. The real deciding factor may not be vision, but touch. Figure repeatedly emphasizes its 3-gram pressure sensitivity. Why 3 grams? That's the threshold where slipping begins. When you hold an egg, too much force cracks it. Too little drops it. Human skin senses micro-friction vibrations. Figure tries to replicate this with high-resolution tactile sensors. Tesla rarely discusses tactile specs. Instead, it focuses on torque control, sensing resistance through motor current. This works for lifting boxes or using drills. But for holding tofu or performing surgery, motor feedback alone may not be enough. This explains why Figure adds palm cameras and advanced touch sensors. They may be betting that pure vision can't solve the final 1% of ultrafine manipulation. For example, reaching into murky dishwater to retrieve a spoon. What does a vision-only robot do then? That's the question Musk must answer. Finally, what does this mean for tech enthusiasts and investors? If you believe in Tesla, watch Optimus's production speed and price. Musk targets $20,000 to $30,000. At that price, palm cameras don't matter. It undercuts competitors by half. Tesla's bet is scale and generality. Just like Model Y didn't win by having the best specs, but by delivering extreme value. And don't forget Tesla's AI compute. If vision-to-action foundation models are solved, even a nearsighted robot can fill in the gaps. If you favor Figure or Sandy, you're betting on experience and specialization. Memo could become the next breakout home appliance after robot vacuums. It doesn't promise world domination, it promises clean dishes. Figure, meanwhile, may dominate high-end manufacturing. In environments requiring extreme precision and reliability, phone assembly, hazardous chemicals, its eye of God and golden hands could be irreplaceable. Over the next 3 to 5 years, we'll likely see clear segmentation. Wheeled, sensor-heavy robots enter homes first. For example, Sandy might enter our lives first because home environments are too complex, prioritizing safety and offering low fault tolerance. In factories, Optimus could deploy at massive scale, like an army. Because factory environments are relatively standardized and tasks are repetitive, this creates the ideal battlefield for minimalist hardware paired with powerful AI to leverage cost advantages. To conclude, this isn't just competition between companies. It's Silicon Valley's best minds confronting the same ultimate question. How do you replicate humanity? Whether through hardware stacking, first principles, or pragmatism, they're all pushing the world forward at full speed. Maybe in a few years, when you're old and sitting in a rocking chair, the hand that passes you a cup of warm tea might be mechanical. When that day comes, we may look back at this video and realize the future began with a hand. Musk believes that within 20 years, work will become a hobby, and Optimus is the cornerstone of that vision. Thank you for spending your valuable time watching. Share your thoughts in the comments. If you want deeper insights into technology and the future, please like, subscribe, and follow me, Money Daily, for timely and accurate analysis.